Okay, today what we'll do is we're going to pick up where we left off in the last class session. What I'm going to do is use the circle that we talked about in the last class session to kind of start the class, and then I'll use it to introduce this concept of functions, introduction to functions, and then we'll talk about the issue of domain and range. You're going to become very comfortable with this vocabulary, and that's just kind of common language that we'll be using throughout this course and any other math or kind of business courses that you take in the future. Okay, so let's go to this circle that we talked about at the end of the last class session. So, in general, if we all know what a circle is. It's a collection of points that are equidistant from some fixed point. It's kind of a formal way of describing it. Here's a fixed point. I'm going to label it in general HK, which is very as a common notation throughout the course. So we have a point that's fixed called HK, happens to be the center, and then we're going to be a fixed distance from that. And now if we keep a fixed distance from that, you can see there'd be an infinite number of points that would create this circle shape. A general point could be labeled anywhere on here as XY. So then you look at the rise between the 2 points we talked last session. The rise is y, here's the y, minus k is this rise, and this run between those 2 points is x minus h. Now you look at the Pythagorean relationship here on this right triangle, and you see that leg squared plus leg squared equals hypotenuse squared. Camera, shift over. Thank you. Very good. Okay. Then, let's say we are going to build ourselves a particular one with some numbers in it. We want the center to be at 5, negative 2. So h is a 5. So we have x minus 5 quantity squared. And k is a negative 2. So negative 2 is a y minus a minus 2. Negative of a negative becomes positive, so it's y plus 2. When you see this structure, and this is squared, and then that's equal to the radius, we decided to pick a radius of 6, so a radius of 6 then being squared is the right side of the equation. When you see this structure, be very careful to realize that this is a shift to the right of 5. Okay, instead of the circle being centered at the origin of radius 6, it's been shifted 5 to the right, and it's been shifted not up, but down. Notice here you're messing with x. Should make sense to you that you're doing something regarding left or right. If it's x minus 5, it actually shifts it 5 to the right. If it's y plus 2, it actually shifts it down. And you can use a little arrow code like this if you wish to help you. We're going to use that idea in this class. Okay. So here's a sketch. And here's the equation. So this is called the standard equation of the circle. And if I draw it, I could come over here 5 minus 2 is the center. And if you add 6 to it, that's going to put this point right down here at what location? At the same level as the center. Excuse me? 11 and negative 2, right? And this point off to the left, right down here, is going to be at negative 1, negative 2. And the top, 5, comma, up 6 from negative 2 is 4, right? And then down, we're still at 5 at the bottom of the circle. 5, comma, 6 below that is negative 8. Okay. Now, what we're going to want to do, let me use this as an example to help us introduce the idea of a function. A function is a special kind of relationship. And the notation we oftentimes use for it is y equals f of x, is the way we say it. I'll write that down here in a minute. A function is you can think of it as a machine. Let me go ahead and use this board. Let me come back over here, actually. You can think of a function as a machine, where a very simple machine, where there's something called an input, which we typically call x, and it goes through some process, and I'm going to call that f of x, and this is the notation we typically use. This does not mean f times x. This does not mean f times x. We speak of it as f of x. And then we create an output value that comes out, and we oftentimes call that y. So now I'd like to, so think of this as a machine. Okay, as a simple machine. You also could think of it as a recipe. A very special kind of recipe. Notice alphabetical order, X, Y. A couple other words that'll be useful here. We also call the things coming into the machine or into the recipe the input. If I could spell. And we call it coming out the output. And you all have cell phones and iPods and stereos and all that kind of stuff, and you always are talking about I/O, input, output. Well, here you go, input, output. The family of all the stuff that could go in that would be okay to put into this recipe, all the possible family of inputs is called the domain. Is called the domain. The family of all the stuff coming out of the process is called the range. Notice all of those combination of letters and words are in alphabetical order. X, Y, I, O, D, R. D, R. Okay. The particular thing about a function is it pass a vertical line test on a graph. The function must pass a vertical line test. Must pass a vertical line test. What does that mean if I draw a graph? If I draw some graph, let's say I draw some looking thing, well, I'll tell you what, let's come back over here and let's go ahead and use our circle as an example. If I pass vertical lines through this is a relationship. This is a visual depiction of this algebraic relationship, right? Okay, here's the image of this relationship. If I pass a vertical line through this sketch, notice it hits. Each of those vertical lines hits in two places. If I'm inside the domain from -1 to 11. If I'm in the domain from -1 to 11, it hits in more than one or more places, doesn't it? If I'm right on the edge, it only hits in one place. But if I'm in between those, in that domain from -1 to 11, if I'm between those, it hits in two places. This would not be a function. What if I just took the top half of that circle? The top half of the circle. Would that be a function? Yes, that would be, wouldn't it? Because if I pass a vertical line through that top half sketch, it only hits once. Similarly, if I just took just the bottom of the circle, it would only hit, a vertical line would only hit once. So the bottom half separately would be a different function. Does that make sense? Okay. So what domain do we have on this relationship? What's the domain? -1 to 11. And that includes the -1 and the 11, doesn't it, as possible inputs? Okay, now again, the whole thing is not a function. The whole thing is a relationship, and this is the picture of that. So, do you all know interval notation? Not the inequality notation, but interval notation? It's something from intermediate algebra, but some of you may be tested directly into this class and don't really know it. So let me show you. What you're probably used to, if I wanted to write down the domain here, I could put from -1 less than or equal to x less than or equal to 11. That's called inequality notation. Inequality notation. Interval notation, I'm going to put next to it. Interval notation is very nice, and we're going to enjoy using it, aren't we? Yeah. Thank you. Okay. And we're going to start at -1. We put a comma. This is our starting point, and we're going to end at 11. Now, how do we denote that we want to include -1? We put a square bracket on it. And over on the right, we want to include the 11, so we put a square bracket there. So anyone that's at this level math or beyond in their knowledge will understand this notation. And all I do is I put a D colon to indicate that I'm talking about the domain of this relationship. And then the range would be on what variable? On variable, right? It's the possible output values. Okay. Now, once again, this is not a function. This is a relation, or a relationship between the variables x and y. And here's the picture of it. Okay. The range varies from how low? Like a water level, -8 up to 4. So -8 less than or equal to y less than or equal to 4. There's a lot of writing there. So we shorthand that by simply going capital R colon -8 comma 4 square brackets, including the endpoints. Feel good? Okay. Keep in mind, this is not a function right here. Feel good? Okay, next step. Let's take this equation, and solve this for y. Let's solve this standard equation of the circle for y. Here's the English comment asking you to put into your work. Solve for y. So the best way to solve for y on this equation now is to leave this structure the way it is, but let's isolate this expression right here involving y. Let's isolate it by taking this x squared expression over here, this binomial square, and move it over to the other side by subtracting it from both sides. So we're going to have y plus 2 quantity squared is equal to 6 squared minus the quantity x minus 5 squared. Now we're trying to solve this for y. So this is a quadratic style equation. It's a second degree equation. And notice that this y is tied up inside this square. So how do we release it? How do we get this y to be freed up? Root both sides, don't we? So by extracting the root, extract the roots, and in math we think of roots as answers, not like a carrot in the ground. Okay, we're going to extract the roots of this. So we square root both sides, so we get y plus 2 equals, be careful, plus or minus a big square root of 6 squared minus x minus 5 quantity squared. Now, we bring this plus 2 over to the other side, and we have got it finished for y. Y equals negative 2 plus or minus the square root of 6 squared minus the quantity x minus 5 quantity squared. Everybody feeling good? Okay. Question, is this a function? Is this a function?
No.
Does it pass a vertical line test? In other words, if you put in one choice of x, you have to be in the domain though, don't you? What's the domain of this thing? Negative 1 to 11. How do we discover that? How do we discover the domain? By looking at the picture. Half of this class is an art class, except we listed it in the schedule of classes under math. Okay? Half of this class is art. You are going to have a tremendous amount of information from these sketches. So we are restricted to inputs between negative 1 and 11, aren't we? Based on what we saw from the sketch. Okay, so those are the only numbers possible here. If I drop some number that's between negative 1 and 11 into it, how many y values would I get out of here? 2, wouldn't I? For instance, let's see what the y-intercepts would be just for the fun of it. If I built a table of values, and this is a simple way you can do it, folks. If I built a table of values, here's x, let's try 0. 0 makes it easy, doesn't it, for x? What do you get over here for y? Come on, quick, arithmetic. You put a 0 in right here, and what are you going to get? 36 minus 25. 36 minus 25 is 36 minus 25. It's positive 11, isn't it? So what we get here is we get y equals negative 2 plus or minus square root of 11. How many values are right there? 2 values. So this thing is not a function, is it? Because it's got 2 outputs for a single input. What would be an easier input to choose, even easier than 0? 5. Right? 5. So what I'm working on is trying to, as I said last class session, I'm trying to help you sort of see things in algebra, and you'll get good with it with practice. If you put a 5 in here, that zeroes this whole term out, and so we're going to get, if I put a 5 in, I'm going to get y equals negative 2, and I'm still in my domain, aren't I? Plus or minus the square root of 36, which is 6, and I end up with 2 values coming out of here. I get a 4 or a negative 8, which you saw in the sketch was the top and the bottom of our circle. Top and bottom locations on the y values. Again, 2 values, not a function. So how do we turn this thing into a function?
Can I ask a real quick question before we move on?
Sure.
If these are if this is inside the domain of the circle, can I just say, well, obviously it's not going to be a function and save myself all this work?
Yes. Yeah. And all I'm doing right now, really, through this discussion, is showing you can build a table of values with any relationship. Like you can build a table of values and actually plot them then, and they'd show up as points on that circle over there. I'm also showing you that what we've got going on here is not a function. Okay. So now, let's do something to restrict this thing or part of this thing and turn it into functions. Turn it into functions. If, as I said earlier, if we took just the top of the circle, wouldn't that be a function? Wouldn't that have an input? Any one of these input, and there'd only be one y value coming out on the top of that circle? Okay. And similarly, the bottom of the circle would be a separate function. So the center, remember, the circle is down negative 2. If it's down -2 and we add something to it, it's going to be the top part of the circle. If we're down -2 and we subtract something from it, it's going to be below that level and it'll be the bottom of the circle. And build two different functions. I'm going to call one of them y1, y sub 1. And let's call that f with a little subscript t for top, using the notation f of x. So this is going to indicate a function describing the top of the circle. So anybody want to suggest what the equation is? Y equals?
-2 plus.
Right, the radical. 6 squared plus minus the quantity x minus 5 quantity squared. Okay? And similarly, I could set up another function. Let me call it f b sub b of x, and that would indicate the bottom of the circle. And that would be -2 minus the radical, x squared minus x minus 5 quantity squared. All right? What's the domain of this top one here?
It's still -1 to 11.
-1 to 11. What's the range of the top one?
-2
To 4, right? Look at the picture if you wish to. See it? And what about the bottom of the circle? Separate domain, or same domain to 11 in the range,
-2 to -8.
-2 as low as -8. Notice the way we always write it, smaller to larger. Smaller to larger. This means left to right in this kind of notation, and bottom to top on the range. We will always do that. Okay. In the interest of time, I already put this into the calculator so we could check to see if this really turned out properly. So with the calculator, let's image. You don't need your calculators, just you can watch, or you can write down in your notes what I did. I actually have it labeled already on the board up here. Y sub 1 is the top of the circle, and here's the equation. You can see it right here. -2 plus the radical, and notice how in parentheses I have embedded all of this stuff in these parentheses that's inside the radical. Here's our 36, subtracting the quantity. I needed a little parentheses here to build the x minus 5 quantity squared. And then similarly, here's the bottom circle, right? And then after you write the equations into your calculator, what's the next step on doing graphing? Next step is
Graph.
not graph.
Window. It's window.
You have to point, imagine pointing a camera. You've got to point the camera to capture what you want. You have to have your left defined, you have to have your right side defined, and you have to have the bottom and the top defined. So by me pushing now the window button on the calculator, here's what I did. I did all my work on algebra on the board first, on paper. Okay? I even drew the sketch on paper. I then used that information to help me define a viewing window to capture this shape. And notice that I set up a window. Oh, and when I'm doing demonstrations in class with a calculator, for notes, all you have to do is write down the things that I give and the 6 numbers I give for a window. Like this. And then the other thing you want to then draw is a image of your viewing screen. And I'll show you how you quickly can sketch these things in your notes or in your homework if you're using your calculator. So I have these 6 numbers now in the calculator. Why did I pick those numbers? Yeah, they're a little bit outside the domain, and they're a little bit outside the range, so that I'll capture this image, hopefully, if I did my equations right. Next step is hit graph. Oh, it stopped. How did I stop it? Midway, partway. Oh, stop it again. How did I stop it? I hit the enter key. The enter key on the TI calculators is your pause. Pause. Also notice that it's drawing both graphs at the same time, instead of just the top part first and then the bottom part second. So I hit enter again, and I'm going to let it go ahead and finish. And don't be too concerned about the little gap right here on the left and right. All it's trying to do is fill in little things called the pixels there, and it can't quite do that. You can actually almost see on the image the width of those pixels. There are 98 pixels across your screen, and there are 62 pixels. Now, is that a circle? It is. Doesn't look like it. It looks like a different geometric shape called an ellipse, an oval, ellipse, sausage, football, something like that, okay? So how can I make it look more exactly like a circle? What I can do is I can go to the zoom key on the calculator, which is up on the top. I hit the zoom key, and we have this settings, and look at number 5. And actually what I want to do first, folks, is I want to show you something. If I wanted to save that viewing window so I don't have to repunch those numbers again, I hit my zoom key, and up at the top here, see memory? So if I use my arrow key and go over here to memory, I can pick number 2, zoom store, and it'll store the window settings in the memory of the calculator, so I can come back to that without having to repunch them. Okay? So I'm going to do that for 2. So it's done. Now I go back to window, and now what I want to do is pick number 5 to square up and undistort the window. Do you see why, if there's 98 pixels across your screen and 62 vertically, that it could get distorted real easily? It'd be kind of like having a distorted fisheye lens on a camera or something, where you could make people look real skinny or tall, fat, or something like that by distorting the image. Your window will do that too. So if I hit number 5, I can square up the window so it's undistorted, and it'll still keep the data in there. And now you see it looks like a circle. The top half drawn separately from the bottom, with a little gap near the ends because it has trouble trying to connect those because they're separate functions. Then on the top of your calculator, you also see a trace key. So if I hit the trace key, it now shows core bottom, it shows the equation at the top. And notice that I'm right now at the center of the screen. At x equals 5, I'm up at the top. If I go down arrow, it'll take me onto the other function. Okay? Now I could use the arrow keys to move to the right or left, like I'm doing. And notice why I set the window with the picture and high enough above the picture. It's so when you turn trace on, folks who are doing calculations where there's stuff on the top and bottom, that it's not going to clobber your picture. So use your brain to build an intelligent viewing window based on your pencil paperwork. Everybody okay? Feeling good? You can clearly see the domain here and the range. Now how could I pin down and check this domain? Make sure it's -1 to 11. I'm in the trace mode right now. Actually, I'm still in trace, so all I have to punch is -1 and see what happens. -1, notice on the bottom of the screen, -1, and I have to hit the enter key. I call that the do it key, and it puts us at that location. Now notice I'm on the bottom. I'm on the bottom function because you can see this subtracting this here. if I go up arrow or down arrow, it'll move me onto the top one. Now I'm on the top one, and if I go, notice it moved me onto a different pixel, and I can come back. I'm still in trace mode. See up here, down here? It's on a different pixel. There's no y value. Why? Why is there no y value? At this -1 value here, -1.1. Why is there no y value shown? Because I'm outside the domain. I'm outside the domain. Is there any real value for that square root if I'm smaller than -1? No, because we'd have the square root of a negative number, which is not real. Okay. So now, how do I get back on that -1 location on the top image? I just punch -1, enter. Okay. So you can move around on the graph like this. Now notice I'm on the top. Let me show you another thing that'll be handy. This is a function. This top half is a function, and so is the bottom one is a separate function. This thing has what's called a maximum, doesn't it? Maximum. Location. A maximum y value. The calculator will find that for any kind of curve, any kind of function you draw. If it goes over a hump and forms what's called a maximum, you calculator do the work to home in on that for you. Okay, here's how you do it. On your trace key, if you use the calculate feature, so you have to use the second key or the shift key and calculate, and so you get this screen. And notice there are a variety of items here. On your homework quiz, you were asked to find zeros of a function, and that's item number 2. Here is how I could find a maximum. So I'm on that top function right now, the circle. So if I pick item number 4, now look at this. It's asking me at the bottom here, it says, give me a left bound. Now I'm looking for this maximum spot, and I'm looking at my scaling here. What's this scale mark right here? Do you remember? It's 2, 4, 6, 8, right? Is the way I set this up. So if I pick a value, a left bound or a lower bound to the smaller side of this location, it looks like 4 would work, doesn't it? So let me pick 4 for my left bound. I punch number 4. Down on the bottom you see the 4. I hit enter, and then notice it puts a little right directed arrow up there. Now let me say 2, 4, 6, 8 is my right bound. I'm going to say 8 is my bound. Enter. Now do you see that interval that's set up? Between 4 and 8. And so why don't I pick 6? It's once a guess, and you have to be inside the interval with your guess. So I'm going to pick 6, which I know is not right. With me? And hit enter, and it does some work, and it homes in on the value, what? That's numerical round, don't worry about it. What's that round off to? 5. 5, 4. And that fits with our pencil paper work. It fits with our mental image and our sketch. Okay? So this is how you use the calculator as a backup tool. Very powerful backup tool for you. Okay. How do you then draw what Victor has done in class? How do you then draw that neatly in your notes and quickly so you can keep up with the instructor? Okay, here's how you do it. Let's come back up here to this. You write down Y1, Y2. You write down the 6 numbers that indicate the viewing image, the viewing window, and then based on what you see the instructor kick up on the calculator screen, you draw your axes. You draw the graph where it hits the axes. You draw it where it hits the top and the bottom. And then where it might be left and right. And then you go ahead and sketch that thing in there. So here's Y1, and then separately, I'll draw it dotted, is Y2. and you label it. And then we also use that maximum feature to determine that we were at 5, 4 for the max location, and we could have done some other things to find the minimum. Now in your homework, you were asked to find zeros, which would be like x-intercepts. So doesn't this thing have some x-intercepts? Right? Not all the heads up and nodding up and down, okay? And so it has 2 x-intercepts, doesn't it? Over here and over here. The calculator can find those for us. The calculator can find those for us. And so what we will do is, in the interest of time, we can do it by hand with algebra, but I want to show you how later does it since that was part of your homework. So how do you find zeros of a function? I have to be on which function to find those zeros? y1 or y2? I have to be on y1, don't I? Because that's the only one that has zeros. Everybody hear that? y1 is the only one that has zeros. Okay? And I'm going to go set this up so I can label those where my y value's showing up as zeros. So that's all set up. I just need to now find those numbers. So back to the calculator screen. I look at my function in the trace mode. I'm on y1, which is the top, which has the 2 zeros. And so I'm going to have to be pretty careful now when I do this. So here's how I do it. I go to the calculate menu again, shifted on the trace key. I select number 2. I can just punch number 2. It's asking for left bound. So what I want to do is I want to home in on this left side, this left 0 first. So I'm going to pick -1. I'm going to pick, I want to be careful. I'm going to pick -0.9 for a left bound, -0.9. Because I want to make sure I'm on that function. Okay? And then I want to be, it's asking for a right bound for that 0. A right bound, so I'm going to pick something like 2. You can see the interval showing up there on the calculator image, and now it wants a guess, and so why don't I pick a guess between those 2 bounds? I'm going to pick 0 for my guess, which would be on the y-intercept, and let it work, and there's the result, -0.6569, 0.6569. -0.6569. Quickly. Tell you what, I'm not even going to take the time to do the next one, but you can eyeball it. 4, 6, 8, 10. We can't go any bigger than 11, somewhere between 10 and 11, right? Somewhere between 10 and 11. So watch this. Let's do some algebra. Have about another minute or so of time left. We are looking for the right 0 on y1 with algebra. Okay? So how do you find zeros of a function? You let
Y equals 0.
x, let x be 0 or y be 0?
Y
We let y equal 0. Okay, let y equal 0. So look at our equation of the circle. X minus 5 squared plus 0, what was it? Plus 2 squared equals 36. There's our circle with y equals 0. Feel good? So we get x minus 5 quantity squared equals 36. This is 4. Move it to the other side. Minus 4 is 32. Sorry for my messy writing. So x minus 5 is equal to 32. So x equals 5. Hold it.
Square root of 32.
Thank you. I knew I had a mistake because I was outside my domain. Okay. Okay, so we have a square root of 32. But square root of 32 is what? Does it clean up? 16 times 2. 4 square roots of 2. And you normally get plus or minus here, don't you? Plus or minus on that? So you get 5 plus or minus square root of 32. Your left 0 is x equals 5 minus 4 square roots of 2. That's exact, and the approximate was what? 0.6569 negative. Sorry for being messy and quick here. And the right 0 is precisely 5 plus 4 square roots of 2. And somebody punched that on their calculator, 5 plus square root of 32. Should be a little bigger between 10 and 11. Excuse me? 10.65 approximately. Okay. There we go. So what we just did today is we reviewed I gave you an introduction to the concept of a function. On the sketches, it has to pass a vertical line test. And then we talked about a domain and a range being the possible family of inputs and outputs. And then we took our circle and expanded on it to find the zeros and the... So you should be getting in pretty good shape on how to use your calculator as a backup tool and how to also distinguish between exact answers and approximate answers. Feel good? Okay, we'll see you next class session. Come see me in the Resource Center if you need any help.